Hi, in this video we're going to discuss about applications of a vector product. Alright, one of the applications of vector product will be finding the area of parallelogram. Alright, so area of parallelogram. So there are, you can even area of parallelogram, and triangle. Right, area of parallelogram and a triangle. So, or it can be used to find the volume of a parallelopipe. All right, can use to find the volume of the parallelopipe, or maybe to find the volume of tetrahedron. All right. So mainly in this video, we are just going to talk about finding the area of parallelogram and area of triangle. Alright, as I mentioned, in geometry, application of vector may apply in area of parallelogram and also the volume of parallelopipe and volume of tetrahedron. So, but in this video, we just interested about finding the area of parallelogram and triangle. Alright, so let's see how to find the volume of, the area of parallelogram. So you know that, let's say there is a parallelogram. Segi empat selari, alright, where they are parallel, right? The opposite side are parallel. So let's say if I said this to be A, B, C, D, right? As you learned before during your school day, you know that to find the area of parallelogram, I need to know the height from the B, right? Either is from D to BC or B to AD, right? So I need to know the height, right? The value of height and the length of the base, all right? And the length of the base. And since this is a vector, right? This is a vector. In terms of vector, let's say if you from A to D, that's from point A to point D. So I've set a direction, so I know that AD. So I can find the magnitude of AD. Right, the length of AD is magnitude of AD, and the length for AB is actually the magnitude of AB, right? Between these 2 points, I can find a vector, and from the vector, I can find the length of the side of the parallelogram, right? As this and this side will have equal length, and this will have equal length. So now, to find the area of parallelogram, all right, area of this parallelogram, all right, so it's the same as you're taking the height. This is the formula that you learned during your school day. So you're taking the height, multiply the length of the base, right? So this is the knowledge that you learned before, where you take the height, multiply the length of the base, then you can get the area of parallelogram. But now I'm going to relate this to a vector product. All right, how to using vector product in finding the area of parallelogram. Alright, so very simple. So as you look at this AD, right? AD. So this AD, and this AD, and this is BC, AB, right? So, and this is H. So I'm going to write out this triangle here. So if you see carefully, I'm going to draw out the triangle. As this, you know, this is the magnitude of AB, right? And you know that there is an angle, right? Angle. I can assume that here there is an angle, right? And there is an angle in between these two vector, right? So then I have this to be H, right? This to be H. So this to be H. So, and I want to write the H in terms of AB and theta, right? Okay, let's see how to write, because I know that this is opposite, right? You know that, and this is a right angle triangle, right? This is a right angle. So this is a right angle triangle, AB, right, to the base. So this is AB to the base. So, and H, opposite, divide by the hypotenuse, right? Opposite, the side opposite to this 90 degree will be hypotenuse, which will giving you sine theta, right? Sine theta. So, okay. And you must remember, this is the angle between AB, vector AB and vector AD. So, if I rewrite that, H can be rewrite as AB multiply with sine theta, right? Multiply with sine theta. So, and I replace H with AB, alright, magnitude of AB, sine theta, right? I replace the H with AB, sine theta, multiply with AD, right? Multiply with magnitude of AD, right? So then later on, I'm going to take AB and AD. I'm going to group the AB, the magnitude of AB, group multiply with the magnitude of AD sine theta, right? So according to the definition of vector product, right? Vector product. Let's say you have an angle AB, right? AB. So there is another, so theta, right? This is your theta. So and AD is another vector, right? AD is another vector. So there is a definition which I can rewrite as you learned before, right? I have tell you before. Let's say if I have vector A, I have vector B, right? Vector A and vector B, and there is an angle in between these two vectors. I can define the cross product, the magnitude of the cross product. This is the definition, right? Which can be written as magnitude of A, magnitude of B, sine theta, right? So means that magnitude of A and magnitude of B, right? Sine theta will be can rewrite this whole thing to be magnitude of A cross B, right? So same thing here. If you see carefully, if you look at this carefully, AB, right? AB, AD, it's just like A and B, right? It's just like A and B. So I can assume that this to be AB cross with AB cross with AD. Alright, if you look at here, magnitude of A, magnitude of B, sine theta. So it will be magnitude of A cross B. And this is the definition of cross product, right? Based on the definition of cross product, if you find the magnitude, and this will be this is actually equivalent. So I can say that the product of this with sine theta is the same as the magnitude of the cross product of AB with AD. Or easier to say, the formula for area of parallelogram is you taking two sides, alright? For example, AB, you cross with AD, then you find the magnitude. You find the magnitude of the vector that you produce. That will be the area of the parallelogram. Alright, this is the application of vector product. Alright, okay, and this is also can be used. This knowledge also can be applied to a triangle. Alright, now I'm going to show you how to getting the formula for triangle. And conclusion here will be area of parallelogram. Alright, area of parallelogram. Area of parallelogram is equals to magnitude of AB cross with magnitude of AC, or CB, CD, the magnitude, or DC cross with DA. Alright, either two sides, so which the vector is came out from the common point from A. So very easy, as long as you remember AB cross with AD, you finding the AD, is AD. So this is AD. Then you will get getting the area of the parallelogram. All right, let's look at triangle. All right, let's look at triangle. So this is the formula for parallelogram. Remember. So okay, let's look at triangle. All right, let's look at area of triangle. Right, it's almost the same. Let's say if I have a triangle, right, of any triangle. All right, any triangle. Let's say if I have A, B, C. If you can understand the derivation of parallelogram, you definitely can understand this. Alright. So as you know that the area of triangle, okay, let's say if I draw from B to the base BC, the AC, right, the base AC. So you have a height of the triangle, right? To find the area of this triangle, area of ABC, triangle ABC, is actually half, right? Half of the height times with the length of the base, as A to C, right? A to C is a vector, so to find the length of A to C will be the magnitude of A to C, magnitude of A to C, right? So now I'm going to rewrite the H in terms of magnitude of A and B. Okay, so then you must know that there is an angle, right? There is an angle between the vector AB and vector AC. So, okay, as I explained before, you know that if there is a definition of cross product, let's say AB, if I'm finding the magnitude of A cross B, right? You look at the start when I discussed about vector product, I have introduced the definition of cross product. So you can rewrite this to be magnitude of A, magnitude of B, sine theta. Alright? So it means that magnitude of A, magnitude of B, sine theta, it will be magnitude of A cross B. So now I want to rewrite this so that it fit this on the right. So I know that this is magnitude of AC, the whole thing here, and this one will be magnitude of AB, the length of AB. Alright? So, okay, I'm going to cut out this triangle. Okay, I'm going to take out this triangle. So this triangle AB, okay, AB, and the base, which will be forming 90 degree, right? Because it's a perpendicular. Okay, it's the height. So theta, and here you have theta. Alright, so how to find the H in terms of magnitude of AB? Right, magnitude of AB. So as I know that opposite, right, the length of opposite divided by the length of hypotenuse. The length of hypotenuse is defined to be sine theta, right? The sine of this theta. So H can be rewrite as the magnitude of AB multiply of sine theta, right? And then I'm going to put this into the area here, so of triangle, so half, and the H can be replaced by magnitude of AB, sine theta, right? Magnitude of AB sine theta with magnitude of AC, and I rearrange. If I rearrange 1 over 2, magnitude of AB, magnitude of AC, sine theta, right? Sine theta. So after this, if you observe, even you have learning additional maths, you have learned that this is also one of the formula of triangle rule, right? Solution of triangle that you learn, that you're using this as long as you have angle. As long you can even use this formula if you have the side AB, the length of side AB and the length of side AC, and there is a given angle here. Let's say there is a given at 60 degree, 80 degree. You can actually plug into this formula and you can get the area of the triangle, right? But the problem here now in this question is they only give you the vector. They does not give you the angle, right? So I need to, with the help of this, the definition, right? So means that I can convert just by using cross product. So the A now in this case is AB, right? And this one will be your AC. So sine theta. Try to compare. I just want you to compare, right? AB, don't look at the half. AB, AC, sine theta, sine theta. So means that the AB is A. So I can rewrite this, the A to be AB cross with AC, right? So finally, the area of triangle ABC can be rewrite to be half, right? Half. This whole thing can be rewrite to be the magnitude of the cross product of AB cross with AC, and this will be the formula for area of triangle. Why I said this is an application of vector product, because to find this area of this triangle with the two given vector, So I can using the knowledge of vector product just by doing cross product between AB and AC, and I finding the magnitude and divide by half, and I will find the area of the triangle. Alright, hope you understand the derivation. Okay, so in the next video, I'm going to teach you how to calculate the area of parallelogram and area of triangle with the formula, right? With the formula. In this video, I mainly just to tell you how to get that formula. Alright, that's all. See you in the next video.